Combining your rules. What we're going to look at today is combining product rule, quotient rule, chain rule, trig rules. Let's see how we do. What's important is being able to identify the overriding rule. So the overriding rule is like the main character in a book or the leading actor in a play. So when you see something times something, what I want in your head is that you're doing a product rule. Something over something, you're doing a quotient rule. Absolutely everything to one power, that's the chain rule. So what do I mean by that? You can see that this little bit is a chain rule because that's an exponent, and this little bit is a chain rule because that's an exponent. But our overriding rule, we have something times something. So this is really a product rule. So this function times this function gives us a product rule. So I'm going to do derivative of first times second plus first derivative of second. Now, how do we do that? I'll write it down over here. It'll be a little bit messy, but perhaps we'll do it gradually and then look at it nice and neat. So derivative of first, you're taking the derivative of x squared plus 1 to the 10. That's our goal. That's a chain rule. Oops, x squared plus 1 to the 10. Let me try that again. Derivative x squared plus 1 to the 10. You'll do that with respect to what's in brackets. And chain that with the derivative of x squared plus 1. So everything we've written down so far is simply the derivative of the first, which is why I often write this little note to myself to tell myself what I'm doing. So that's the derivative of the first. That gets multiplied by the second term. So that's our x cubed minus 1 to the 5th. Then we add the first term, x squared plus 1 to the 10. And that gets multiplied by the derivative of the last term. Ooh, there's a lot going on. So hopefully you know your rules by now. So that would be the derivative of x cubed minus 1 to the 5th. You chain that. First take it with respect to what's in brackets, which is your x cubed minus 1. And then multiply that by the derivative of x cubed minus 1 with respect to x. Okay, so let's see if we understand what just happened. Derivative of first multiplied by second plus first derivative of second. You want to see it a little bit neater? It'll look like that. Okay, what shall we do next? We're going to work out all these steps. So chain rule, we'll do a substitution, make that an a. So derivative of a to the 10 will become 10a to the 9. Derivative of x squared plus 1 is 2x. Do we have to do anything with that? That was just the second, wasn't it? And you can tell you don't have to do anything with that because there's no d's by it. So it's already done. So we just get to write that one down. Okay, then we have the x squared plus 1 to the 10. Again, that's already done. We don't need to do anything. Oh, these chain rules, these were just the steps. We haven't actually done those, so we'll keep going. Derivative, could make that an a if I want. Derivative of a to the 5 would be 5a to the 4. And a stood for x cubed minus 1. And then derivative of x cubed is 3x squared. So it's a lot of writing. You're writing down your steps and then you gradually do your steps. We want to see that a little bit neater. It looks like this. Instead of a, we replace it with x squared plus 1. And that is a fine answer if I don't ask you to simplify. So often tests and exams will say, don't touch it. Do not simplify, leave it as it is. And the truth is a lot of universities do the same. But occasionally we're going to say, please simplify. And then there's a lot of work. We're going to put all common factors at the front. So what should we do first? We'll notice that 10 and 5, they have a 5 in common. So we'll pull the 5 out. When they pull the 5 out, From the 10, there's a 2 left. And from the 5, nothing left. Everything else gets written down again. What else can we find? There's an x squared plus 1 to the 9 and an x squared plus 1 to the 10. They each have 9 in common. So you'll see that they're all gone from here, but there's a 1 left from there. So we're just pulling the common factor of 9x squared plus 1's out front. I'm just going to write it down again on the next slide, and we'll see what else we can pull out. We can pull out 4 of these. Where did they come from? 5 of them there, 4 of them here. That leaves 1 inside. Is there anything else we can do? Yeah, we can take 2 times 2x and make it into a 4x. Is there anything else we can do? Oh, yes. We can multiply those out. So we could multiply 4x by x cubed, 4x by minus 1, 3x squared by x squared, and 3x squared plus 1. And then combine your like terms. Now, why would I ask you to do this? Eventually, we're going to be saying, where does this equal 0? And now we can say it equals 0 at 1, and whatever would make that equal 0. And we had no way of knowing that if we left it up here looking like that. So we will be doing some factoring. At the moment, you're practicing it just for what we need to do later. And again, watch the test to see what the question is. If it says, do not simplify at all, don't touch it. Let's do another one. Okay, the overriding rule. Maybe we should rewrite it first. I see absolutely everything to an exponent. Therefore, it's a chain rule. The chain rule says, take the derivative with respect to what's in bracket, take that derivative with respect to x. Okay, let's start with that on the next page. So we could pretend that's an a. Derivative of a to the 1/2 with respect to a would be 1/2 a to the negative 1/2. What's this other bracket all about? That's a quotient. If you just looked at that by itself, you'd have to do the quotient rule. Quotient rule says derivative of top times bottom minus the top times the derivative of the bottom all over the bottom squared. All right, bottom squared would be x squared plus 1 squared. And I'm going to write that out neater so you can actually see what I'm doing. Looks like that. So we said 1/2 a to the negative 1/2, and a stood for this. This rule was the quotient rule, derivative of top times bottom minus top, derivative bottom, bottom squared. Now what can we do to simplify this one? We could multiply all these out, and we generally do that with the tops of quotient rules. The reason we do that is often things will reduce and often things will combine. So if you are asked to simplify, expand the top of the quotient rule, collect all your like terms. Then look for the standard simplifications. Negative exponents, make them positive. Change something to the half to square root and put any single terms together. So where do we go from here? Well, we were left with 4x because the x cubes went, and 2x and 2x is 4x. I think I might be tempted to say 1/2 of 4x is 2x. I guess I'll do that later. Let's deal with a negative exponent first. A negative exponent means flip it over and make it a positive exponent. What just happened? So if you have 2 to the negative 3, that becomes 1 over 2 cubed. So what you really did is you took 2 over 1 to negative 3 and made it 1 over 2 cubed. We did the same thing here. Flipped it over, positive exponent. Instead of a 1/2, we'll make it a square root. And then there's the promised take away the 2's. Ooh, these are intense. Let's do another one. Ooh, what do you see here? I see this is one term. This is another. This looks like a quotient rule to me. So again, the reason it's not a chain rule is not everything to the same power. We're doing a quotient rule. Quotient rule says take the derivative of the top, multiply it by the bottom, minus the top, derivative of bottom over bottom squared. I'll write it out here. It's going to be a little bit messy, but we'll try. Derivative of top, that would be a chain rule because it's raised to an exponent. So we take that derivative with respect to what's in brackets. Then we'd multiply that by the denominator. So that gets multiplied by 5x plus 1 with respect to x. That's derivative of top. Gets multiplied by bottom minus the top times derivative of bottom. Ooh, we know that one. We just write down 3 all over the bottom squared. Okay, so it was the quotient rule, derivative top times bottom minus top, derivative bottom, bottom squared. Looking nice and neat, it looks like this. We'll do a little substitution here. That would give us 3a squared multiplied by 5, write down the bottom, write down the top, derivative of that was just 3, bottom squared. And after we did 3a squared, we substitute back for the 3. Put your single terms together. So if you're asked to simplify, put common factors at the front, expand the top of the quotient rule. So I guess instead of multiplying it out, it might be smarter to factor. How does that look? Let's see what we can do. Are there any common terms we can look for? Because there's a common term of 3 and 5x plus 1. Okay, there's a 3 here and a 3 here, so we can pull that out. And 5x plus 1 squared, 5x plus 1 cubed, we can pull out 2 of them. That's smarter than just expanding, isn't it? So be careful. You might be tempted to go, yeah, I'm just going to pull everything out front, but it's quicker if you look for your common factors first. And when they're this big, there's always going to be common factors. All right, what can we do now? We'll multiply these out next. So what does it look like when we multiply those out? (15x minus 5 minus 5x minus 1). Then collect your like terms. And we're left with the 3, the 5x plus 1 squared, 10x minus 6. And again, why are we doing this? If I asked you to say, where does this equal 0? You could say it equals 0 at negative 1 over 5, twice if you were graphing, and 6 over 10, which is the same thing. Oh, there's another, that's a 3 over 5. So your aim is to take derivatives as fairly complicated questions by identifying the overriding rule. Is it something times something, which makes it a product rule? Something over something, which makes it a quotient rule? Absolutely everything to 1 power makes it a chain rule. So that's what you need to identify. And then I really, really, really recommend writing this down, because otherwise sometimes we go, oh, look at us, we've done all this work, and we forget that there's all the other steps. So as always, do all the work. Lesson 4, exercises A to T. The more you do, the better off you're going to be. All right, off you go.